Design Phase 3. We are Dungeons and Variables. My name is Candace.
My name is Caleb.
And my name's Tommy.
So in this presentation, we'll be going over our use case scenario, updating you on our process through the Gantt chart. We'll be going over product architecture as well as the computer-aided design models of our project. We'll also have a video for you to demonstrate how the BRG works, as well as BRG performance rating chart. We also go over the cost to manufacture this project and what we expect to make out of it in profit, as well as where we could improve on the actual design of the BRG through failure modes and effects analysis.
For our use case scenario, we have a Rube Goldberg device, which involves a 3-obstacle course, which is catered towards 8th and 9th grade students, so the middle and high school level. At this age, they're learning how to find variables in their algebra classes, and although they are currently not taking physics, we are also introducing some simple physics concepts. To help quiz the students who use this BRG, it is question-answer based, so the Arduino program will display a question on the screen for the user to answer, and afterwards will display the correct answer. If the user gets the answer correct, then the Arduino or the BRG will display correct angles and heights, and if the user gets the answer incorrect, then the BRG will display incorrect angles and heights, which therefore the ball cannot complete its course.
So throughout the project, we've been tracking our progress with the Gantt chart. We have progress bars inside of task bars to show how much each task is complete. And now that we're at the end of our project, all of the bars are filled in. So that means we can go back and revise where we need to and move on to the next phase of manufacturing. In order to help identify our customer needs, we identified people based off of our customer profile to get feedback. So we had 4 teachers and 3 middle school students who were available for questioning. But some of the questions we asked included if they did much hands-on work in class, or what subjects they were working on, or if they preferred multiple choice tests or free response tests. And this gave us some good feedback.
For product architecture, our bold solid lines represent our flow of forces or energy, our non-bolded solid lines represent our flow of material, and our dotted lines represent the flow of signals or data, which is our software. So our first chunk involves our user software interaction, which begins with the Arduino, which will display a question, and the user will have to input the answer to display an answer, and how the BRG reacts to that is dependent on whether the user gets the question wrong or right. The Arduino will also signal the motor to run, which is our main power supply, which runs the kinematic elevator. And then the elevator is one of our obstacles, which is also connected to our spring cannon and our velocity tunnels. The last 2 parts of our BRG involve the entrance ramp and the exit ramp, which is connected in the beginning and the end, and that is part of our BRG mechanism, which is all the physical parts of our project. That does not have to do with the electrical works of it. Our hardware interaction involves our wire placement, in which the user would have to switch the color-coded wires and whether or not they want to restart the BRG, or if they just want to manually control the height of the elevator. And then our last chunk involves the user interaction, which is the only other force other than the motor, and that's the manual force in which the user would have to use their hands in order to work the spring cannon.
This is our 3D CAD model of our design. We have the spring cannon, the kinematic elevator, and the velocity tunnels. The ball enters the spring cannon first from an entrance ramp. The user pulls down the spring, which will launch the ball at the proper velocity into the elevator, which then, if that's at the right height, it will roll successfully into the velocity tunnels. From there, the user selects which tunnel the ball rolls through. and from there, if they get it correct, then the ball proceeds to the exit.
One ball which is already loaded within the spring cannon. All you do is place the balls in the cannon and making sure that the platform is at the bottom. So since we already have a ball in use, we can just use this one at the moment. So we have it already loaded in here. It's on the platform. We're going to raise the platform. You can just take your fingers like that. And then making sure the platform is all the way at the top, and if you want to check and look under it, you can see that it's very flat. And you're going to make sure that the tube is over the lift so that the ball drops straight into there and completes its course. You're going to take your 2 rubber bands that come in the kit and place one on each side of the spring stick. You're going to take your fingers and place them within the rubber bands like so. And you're going to raise your fingers up the tube, creating tension. Take your other hand and place them on the stick, creating a C-like shape with your fingers. And when you're ready and you feel that there's enough tension between your rubber bands and your fingers, place your fingers on the stick and you're going to go down. And that is how our BRG works. Thanks for watching.
Some of the primary drivers for why we want it to be environmentally friendly included cost reduction, which would mean less use of raw materials and hopefully less manufacturing cost. So it'd be a win-win situation, as well as against competition, we would be favored by the public as more environmentally friendly. So one of our most important goals for this project to reduce environmental harm would be to eliminate toxic and dangerous packing materials, which could be very dangerous in a landfill or to people buying the product. One of the greatest environmental impacts we'd like to avoid would be natural resource depletion, because that would mean wasting of materials, and if we can cut down on that, it would also lead to reduced costs. So the 2 primary guidelines we put in place for our project included employing folding, nesting, or disassembly of our BRG so that it would be able to compact down to a smaller size and require less packaging. And we also wanted to ensure that joints and fasteners are easily accessible, like our springs and various plastic parts could easily be found or reproduced without much effort.
We performed a quick performance rating on our BRG, and we came up with 5 different categories: quality of the interface, the emotional appeal, ability to maintain and repair the product, appropriate use of resources, and product differentiation. We came up with different ratings for each of that. One of the main things we found was this product is easy to maintain and repair because it uses low-cost materials, but due to this, however, it has very low strength and may break down more often than other ones. Therefore, this product leans towards the do-it-yourself type personality that likes to fix things and work on things themselves. Listed over here is the estimated cost to manufacture this product. As you can see, the majority of the cost comes from the Arduino and paying the workers to assemble this product. Most of the items cost about less than $1 to $3. So overall, it is a very cheap product with an overall price of $65.62. Since the total cost to manufacture the product comes out to be about $65, this is about $10 less than what we previously estimated during the beginning of our product planning phase. Therefore, when we rerun the whole economic analysis, we come up with a new max profit of $35,562, which was originally $29,000. That's about a $6,000 increase in our maximum profit. Also, our break-even points changed to make it more convenient and easier for us. So I ran a quick failure modes and effects analysis of our BRG, and the greatest chance of failure was with the kinematic elevator, in which the motor would not work. Possible causes of this is that maybe a wire shorted or the whole wire was fiddled with incorrectly. The ways we could fix this is having clear instructions on how to set up the wiring for the Arduino and testing the motor to make sure it's not faulty or it works correctly. So in this report, we went over the CAD model and showed how the BRG is in use. We looked at the BRG and how it's going to help the environment. We looked at the performance rating of the BRG. We also went over the maximum profit with the new cost to manufacture the BRG, and finally, possible failures of our BRG.